I did. Okay, folks, let's talk about a new lecture. This is a lecture on the rational expressions, and this is the first part of that lecture. We are going to have the second part, and because it's a little bigger topic, so that we have to spend a little more time talking about it. What is a rational expression? Well, it's a fraction of two polynomials. So, for example, we have something like this. We would call that a rational expression. So you have one polynomial in the numerator, x plus 2, and the another polynomial in the denominator, 2x squared minus 5x plus 1. It could be anything we regard as a polynomial. So it could be something very simple, like this. Now this by itself would be polynomial. So you have one polynomial on the top, x plus 2, and one on the bottom, 2. You can actually write that, it's a half, right? Half of x plus 2, you could write it as a 1/2 of x plus 1. The half of x plus 2, you can divide x with 2 and 2 with 2, separate that, and then you get a polynomial. So this is actually a polynomial. So rational expressions are actually polynomials as well. Some of them are polynomials, excuse me. So for example, this one also, x plus 2, is the same thing, right? But there are other things that are not polynomials. So if we have something like this, then we are dealing with a rational expression that is not a polynomial. So you have polynomial on the top. This is a third degree polynomial. You have a cube here. On the bottom you have a polynomial which is the second degree, or quadratic polynomial. We sometimes say as second degree polynomial, a trinomial, right? And so trinomial on the top, trinomial on the bottom. And this is a rational expression. This is definitely something new. We didn't have that as a polynomial. This is not a polynomial. Okay, so what is this about? Well, this is about generalized fractions. So if you had a problem with fractions, now you're going to have a much bigger problem, because you're going to have to deal with the fractions that are variable. So you have on the top something that is variable depending what an x is, on the bottom something that is variable again depending what an x is, and the whole thing is a variable fraction. If you put x to be of some value, then you're going to get evaluation, you're going to have some concrete fraction. But in general, this is just a variable fraction. Okay, so this is something that is more general than your regular fraction. So to be able to handle this stuff, you definitely need to know a lot about fractions. Okay, and there are lots of things that we are going to be able to do with these guys, the same thing we were doing with fractions. So one new thing you're going to ask yourself, what is the domain of rational expression? Okay, that is very often the question that is asked. The domain of rational expression is whenever you can calculate this. Meaning, what x can you use to get actual number, concrete number? Better question is what you cannot use. Well, you cannot use this guy being 0. Because if this guy is 0, you will be dividing with 0. And when you divide with 0, there is no result of that division. We say it's undefined. You cannot divide with 0. So in this particular case, you're looking at the rational expression that has a domain, something that downstairs could not be 0. So now I know also that I can factor the denominator. So I can do something like this. Right? This is identically equal to this, because when you multiply x plus 2 and x plus 3, you're going to get an x squared plus 5x plus 6. Because of that, this is identically equal. So whenever I place any kind of x, whatever I got here is the same as I get over there. But I cannot calculate that one if the bottom is equal 0, which means that x is equal -2, or where x is equal -3. When x is equal -2, this is 0. So I get 0 times something which is also 0, and then I have to divide with 0, no result. If x is -3, I got this guy, -3 plus 3 is equal 0, so I got 0 times something, that would be 0, and then you end up with the denominator being 0, so you have to divide numerator with 0, and of course you cannot divide, so which means the domain of this expression are all reals, all real numbers, with 2 exceptions. Except -2 and -3. So that is what a domain is. Again, domain of rational expressions are all of the numbers that you can possibly plug in here and come up with an evaluation, come up with some concrete value. In case of -2 and -3, if you plug it in here, you will have to divide with 0, and therefore you're not going to be able to come up with anything. Let me give you another one. Okay, what is the domain of this rational expression? Again, I have something on the top that is a polynomial too. Yes, number by itself, but it's also polynomial. On the bottom I have binomial x minus 5. What is the domain of this rational expression? All real numbers except 5. Again, if you plug in 5 here, you're going to have 5 minus 5. It's going to be 0, and then you have to calculate that. You have to divide 2 with 0, and you have no result, and therefore domain of this expression cannot have 5. Anything else? Yes, of course. You can plug anything else, you're going to have something different than 0, and you're going to be able to divide, you're going to come up with some number. So this is about the domain of rational expression. So this is something new. You have never done this for regular fractions. The fraction is either concrete value or it's violation of algebraic grammar. For example, sometimes people write stuff like that. That's of course a violation of algebra, because this is not a number, right? You cannot divide 3 with 0. So we don't worry about it with fractions. But with rational expression, we do have to worry about those kind of things. What else you do with fractions? Well, you build them up and you reduce them. So there are 2 things you do with fractions very often: building it up and reducing. Building it up, when you need to add them, you need to have a common denominator, so very often you need to do that. So for example, if I for some reason want to have a denominator 12 here, I need to build up this fraction so that I can have denominator 12. And how is that done? Well, to get 12 out of 3 is by multiplying with 4. So to get the same value for my fraction, I need to multiply x with 4, so I get 4x. So this is building up. I am multiplying up and down with 4. And this is identically equal to this, which means that you can plug any value for an x, and this will be the same thing as this one here. So this is the build-up. We often do the build-up because we need to have some different denominators. That whenever you need to have a different denominator, whether it's an LCD or something else, you will probably going to be building up the fraction. That could happen also with variables. So for example, I want to build up this into a fraction where the denominator is going to be x squared minus x. Now the question is how you're going to do that. And sometimes people think, oh, okay, I have an x squared, I just multiply with an x and that's it. Actually, no. You have to really figure it out. How is this made out of this guy? And to do that, you need to do the factorization here. This guy here ought to be factorized. X squared minus x is equal to x times x minus 1. So you actually have an x and x minus 1. So now you can see what you need to do. To get from this guy to this, you need to multiply with x minus 1. But you do the same thing with the top, and you're going to multiply with x minus 1. Not just with x, but with x minus 1. And you're going to have 2 times x minus 1. You could leave it this way. This is called factorized format. Or you can just multiply and get that without parentheses. You have 2x minus 2 on the top, and on the bottom you have an x squared minus x. So I build up this guy into that guy. Interesting, right? So that looks quite different. Why would you even want to have this guy here instead of this? Well, maybe because you need this denominator. Maybe that's the requirement that you need for whatever the addition you might have. Let me give you one more example. There are more examples in the lecture. The lecture is on the blackboard. You should actually study that lecture. I'm going to give you another example. Let's say I want to build up x plus 2 divided with x plus 3. That's a perfectly good rational expression, but all of a sudden I want to have, because of some reason, I want to have downstairs x squared minus 4x minus 21. How am I going to do that? So again, I have this guy here, and all of a sudden I want this guy here. So I'm not happy with this denominator, I want to have another denominator. The reason might be because I am looking for a least common denominator, because I'm performing some addition or some subtraction. Okay? Maybe you can do it. To be able to see that, you need to actually factor this guy. And if you factor this guy, you will notice that you have x plus 3 and x minus 7. What am I saying here is you need to know the factorization. Now, this is the previous 2 lectures we were doing, lecture number 12 or lecture number 13, when we were factorizing. If you don't know to factorize, you're not going to be able to do that. So I just factorized this guy. So this is what I have. Now you can see that going from this one to this one, I am multiplying with x minus 7. Which means that I also have to multiply this guy with x minus 7. Okay? So my new numerator is going to be the old numerator x plus 2 multiplied with the new numerator x minus 7. And now you can say, oh, I'm done. But this is really not very aesthetic, because on the top you have a factorized, on the bottom you don't have factorized. So maybe you can leave it this way on the bottom and this way on the top, which will be in a factor format. But I'm just going to straightforward multiply, so I can get something that has no parentheses. On the bottom I have good old x squared minus 4x minus 21. And on the top I have x squared minus 5x minus 14. Surprise, surprise, this guy and this guy are, I should say, almost identically equal. There is one case when they are not equal, because they actually have different domain. This one has a domain everything except negative 3. Negative 3 cannot be calculated. This one actually have also negative 3 to be excluded, but also 7. Now that's a different story. We're not going to be spending time on that, but in general they're almost identical. So this guy and this guy could be used in most of the applications as the same thing. So we have this fraction, which is not very complicated, and then all of a sudden you have a lot more complicated fractions. So again, why would you need that? You would need that if you want to build up your old fraction into something that would have common denominator with something else, because you're planning to do something like addition or subtraction. When you do addition or subtraction of fractions, you always need a common denominator, or most of the time you need a common denominator, so there might be need to build it up. Okay, so build up is a thing we do with rational expression. We also do the reduction, reducing to lowest terms. Okay, that's not news to you either. That is often done with the with fractions, reduction. So here's an example: 2x on the top, 2x minus 6 on the bottom. If you want to reduce this, you can reduce this by reducing common factor. It's called canceling common factor. It's not really canceling, you're dividing up and down with a common factor. Okay, typical mistake that people do very often, they just cancel 2x and 2x. You cannot do that because this 2x is not a common factor. It's not a factor at all. It's a term. So you have term here. You cannot cancel term. You can cancel common factor, right? So people often do this stuff like x plus 1 over x is equal 1. No, it isn't. Okay? It isn't equal 1. You cannot cancel this and this because this is a term, not a factor. You can actually check it out. X plus 1 over x. If x is equal to 1, you have 1 plus 1 over 1, which is 2. It's certainly not 1. So if x is equal to 1, this is 2 and this is 1. So that's not equal. Cannot cancel terms. If you're canceling, you must have a factor. What does that mean? That means you need to have factorization. Now the top is already factorized. It's 2 times x. So that's fine. You have to factorize the bottom. So you have a common factor 2 and 2 here, so you can factor out 2. So now you have an x minus 3. That's your first job. Now you have factors. Factor, 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 factor. Is there a common factor? Yes, it is. It's right here. 2 on the top, 2 on the bottom. Once you have a common factors, you can cancel them. You're basically dividing up and down with the same numbers. So that's what's called cancellation of a common factor. You're dividing numerator and denominator with the same number, which is what we are allowed to do, and the fraction will stay the same as before. So if I divide, I mean identical. If you divide with 2, 2x divided with 2 is an x, right? 2 times something divided with 2 is that something. And the same thing on the bottom. 2 times something divided with 2 is x minus 3. So you end up with x on the top and x minus 3 on the bottom. So that's the cancellation of a common factor, or a reduction. Sometimes people also use the word simplifying. Whatever that means. Simplify is an eye of the beholder. If you're not told what simplify means, it could mean lots of different things. Let me give you another example. So I have 2x squared minus 2 divided with the 6x squared plus 6x. Okay? Obviously, this is not, this is not entirely obvious that this could be reduced, but let's say somebody's asking, reduce this. What does that mean? It means, again, you're going to have to factor it. Because if you're going to be reducing, you're going to be canceling or a common factor, reducing with common factor. So on the top, you need to reduce that. You need to factor it. So if you factor the top, you have definitely a common factor, x and x squared minus 1. 2 and x squared minus 1, right? Then you multiply 2 times x squared. 2 times 1 is 2. And on the bottom, you can also take out the 6x as a common factor. You can see that. 6x is a common factor, and you have then, if you take 6x, there's 1x left here. And if you take 6x out, there's 1 left, right? That's the good old story we have. You think maybe you're done now, but you're not done. So let's see what else. This is difference of 2 squared, x squared and 1 squared. So we know that that could go in x minus 1 and x plus 1. So now you have a complete factorization on the top. That's a 1, 2, 3 primes. On the bottom you have 2 times 3 times x plus 1, right? I just split the 6 and 2 and 3, or 2 times 3, 2 times 3. This is not the first time you've seen that, so I guess you will know that. And I can now cancel common factor, common factor, common factor, common factor. Okay? Everything on the top is 1, 2, 3 are factors. Everything on the bottom is 1, 2, 3, 4 are factors. And I have 2 common factors on the top and 2 common factors on the bottom. I mean, the one on the top relative to one on the bottom. Another one on the top relative to another one on the bottom. So now you can finish the problem by writing what is the leftover. On the top you have an x minus 1. On the bottom you have 3x. In a test situation you should actually check that. So you should plug something. Plug some value for an x and plug some value for an x here and make sure that this is the same as this. Okay, that's important. Right? If you don't do that, might be a, you know, the idea might be okay, but your work might not be okay, so you're not going to find a mistake. So let's say I can plug in value 3. If x is equal to 3, I have 2 times the top. 3 squared minus 2. On the bottom I have 6 times 3 squared plus 6 times 3. And what am I getting here? You can use this calculator for this, right? So you have a 9. 2 times 9 is 18, minus 2 is 16. On the bottom I have 9. 6 times 9 is 54. 6 times 3 is 18. So you have a 72. Okay? And yeah, I can reduce this 18 and 54 and 72. I can reduce this by doing something. Well, I'm just going to work this out. So you have the so the top is equal to this, the bottom is equal to what? 3 minus 1 over 3 times 3. And x. So I'm getting 2 over 9. Yeah, this is equal, right? If you multiply this with that, you get 16. You multiply this with that, you get 72. So now you know that this and this are equal things. Well, not exactly, because there might be another number that might make it different, right? But at least you have some check. I checked this for 3, and you can check for some other number if you like. You can check for negative 1.7 if you want. Yeah, probably you don't want to do that, right? Don't check with those coincidental numbers 0 and 1, because they can give you, there's lots of coincidences with 0 and 1, so you have to use something else. So this is a test situation, just to make sure that everything is right, because if you made a mistake somewhere on the way, you will discover that if you check it. If you don't check it, well, you might have, this is one of those times that people say, I have made a stupid mistake. Well, I don't know, mistake can be stupid, right? So the story is that you were careless and your algebra is not working well. Okay, let me give you another example. So I have, again, the lecture has more examples, so you will need to read that, right? So I have 3a squared minus 6a, so I said nowhere you should expect that you must get the x around, you might get polynomial with something else. On the bottom I have a 5a cubed minus 20a squares, and I have one more 20a. Okay, so again, somebody's gonna say reduce this or simplify this. What does that mean? Make it look nicer, smaller, right? Reduce it, that means that's a particular thing to do. You need to reduce it by canceling common factors. So that's not in the eye of the beholder. That's exactly, you know, what it means. You need to find all of the common factors and cancel the common factors on the top and the bottom, and that's reduction. And simplifying, as somebody says simplify, that could mean who knows what. But the reduce this, that's clear. Okay, so to reduce it, I need common factors. I don't have factors. This is the term, this is the term, this is the term, term, term. So I have all of them, all of the things, most of the things I see are terms. So I need to factor that. On the top I can factor that common factor is 3a. So 3a, you see here 3 and a, and here 3 and a, so what is left is a minus 2, right? I didn't write this too nicely, let me try again. So I have 3a times a, which is 3a squared, and 3a times 2, which is 6a. That's the top. That was easy. On the bottom I have a little more work. I do have a common factor, which is 5a. I can see 5 here. 5 times 4, 5 times 4, right? So that's 5. And also I can see an a in all three of them. 3a's here, 2a's here, 1a here as factors. So I can take 1. And now what is left is a squared. The second one is negative 4a. And the third one is 4. And it's just positive 4. Right? I hope I copied this right. Yeah, it's positive 4. Okay, so now you can say, oh, I see a common factor. I have an a and a here, I can cancel a and a. So, okay. But you're not really done yet, because this guy here is not a prime, so you can go further. So this is not a complete reduction. There's more. So I have on the top, I cancel the a, so I remove the a. On the bottom I have 5, I remove the a, I cancel it, and the second one is a perfect square. You should recognize that. A squared, 2 squared. Then you multiply that, it's 2a, and you double that, it's 4a. So this is a form, square of difference. So you have a minus 2, a minus 2. This is often written just as a square. I'm deliberately writing a minus 2 because I intend to cancel one of them with one of these guys on the top. So I have clear vision what is left. On the top I have 3, on the bottom I have 4a minus 2. So I can also write that as 5a minus 10 if I don't like to see parentheses, right? So here is the reduction again. So we reduce this, okay? Let me give you one more. This time I have a rational expression that has 2 variables in it. 2x minus 2xy. On the bottom I have 4y squared minus 4. Right? So I have 2 variables. I have an x and y. But again, still, reduction is possible, so I'm going to reduce this. And what I'm going to do here is I'm going to factor first. On the top I have 2x and I have 1 minus y. On the bottom I have 4 as a common factor, and I'm leaving y squared minus 1. So extract the 4. 4 times y squared is 4y squared, and 4 times 1 is 4. This is not done yet because this guy here has difference of 2 squares, square of y, square of 1. So you need to do the one step further. So you have 4, 2 times 2, right? And on the bottom you have y minus 1 and y plus 1. That's the factorization of a difference of 2 squares. So now you have common factor 2 and 2. And cancelling, you're actually dividing up and down with 2. And also you have the 1 minus y and y minus 1. These are opposite numbers, right? We talked about it before. And when you canceling opposite numbers, you end up with minus 1, right? 3 divided with negative 3, you can cancel, but the result is negative 1. Or negative 7 divided with 7, the result is negative 1. The same thing here. If you cancel this guy and this guy, the result is negative 1. So you have on the top negative. The negative has to pop up somewhere, maybe in front, like this. Okay? And you have an x. So I cancel this one and this one, but the negative 1 stays. So I put that negative 1 in front. If you multiply numerator with negative 1, is the same as if you multiply denominator with negative 1. And that is also the same as if you multiply the whole fraction with negative 1. right? I'm saying negative 1 over 2 is the same as negative 1 over 2 is the same as 1 divided with negative 2. So you can put this negative anywhere you want it. I put it in forward. You have to be careful though. If you have two things like x minus 2 over 2 and you have a negative in front, you cannot write negative x minus 2 over 2. That's wrong. You have to multiply the whole thing on the top with negative, so you need to do the plus here. So this will be equal. So if you multiply the whole fraction with negative 1, is the same as if you multiply numerator with negative 1, which is what you get here. Which is also the same as if you multiply the denominator with negative 1, which is what you get here. Trickery, right? So be careful with negative. But in either case, if you cancel this one and this one, negative 1 stays somewhere. I'll put it forward. So I have x on the top that is left. What is left on the bottom? This guy and this guy. So I have 2y plus 1. And now I can finish the job. I have negative x on the top, and I finish job, I mean get rid of parentheses. So you don't have to, but I'm going to do that. And this is it. Okay? So this is a little trickery here. I had these difference of squares, I had a common factor, I also have a cancellation of the opposite numbers which produces negative. Sign of negative. You gotta always remember that. Okay? What else you do with fractions? Well, you add them, multiply them, divide them, subtract them. We will talk about addition and subtraction the next time we meet. So I'm just going to talk about first about multiplication. Multiplication is very simple. The principle is you multiply numerator, numerator, denominator, and denominator. But if you're just doing numbers, something like this, you can just multiply the top, which is 3y minus 1 over y plus 3. That's a mistake, right? If you multiply the top, you multiply everything, so it's going to be 3y minus 3. Right? Some people say it this way, which is nothing wrong with that. 3 is the same as 3 divided with 1. Yeah, it is. So now I have this times this. Numerator times numerator. But again, remember, you need to multiply 3 with all of that. So you need to probably write that if you don't see. If you don't see ahead, write it down. And now that you multiply 1 times this, which is the same thing, so you don't really have to do much. And on the top now you have a 3y minus 3 over y plus 3, which is, again, the same thing as I had before. So you might want to remember that when you multiply with something that is not a fraction, just one value, not a rational expression or not a fraction, you just simply multiply the top with that number. Or, if this makes you more comfortable, do it this way. It's the same thing. Okay? Let me give you one more. So I have another one like that. 2y times 5 over x. Okay. What we have here, so I'm multiplying the top. And I get 5 times this guy, which is 10y. And down there I have an x. That's a fast way. Or if you really want to see it this way, 2y is 2y over 1. If you divide with 1, you get the same thing. And you have y over x. And now you multiply the top, you get 10y. And on the bottom, you get 1 times x, which is an x. One way or the other, you get the same thing, right? Okay? Now, what if the stuff is not exactly a single number, but maybe a fraction, not multiplying fraction with fraction? Okay, so I have an example here. 2x over x squared minus 4 multiply with x plus 2 divided by 2. Okay, something like that. What you're gonna do first, like with numbers, you can either multiply and then reduce, or you can reduce and then you multiply. That's what you do with numbers. So, I don't know, example like this: 2/3 times 6 over 11. You can multiply and you get 12 over 33, and then you realize, oh, I have 3 and 3 up and down, so divide with 3, I got 4 over 11. So this is, you multiply 2 times 6, 3 times 11, reduce, divide with 3 up and down. Okay? You can do it with numbers. It would be also smarter if you could notice that you have here 2 times 3, and you have a 3 times 1. So you can cancel 3 and 3. So you have 2 times 2 and 11 on the bottom. This way, you do the reduction. You do the reduction before you do the multiplication, right? First cancellation, then multiplication. That's another way to do that. So with numbers, this is not a problem. But with rational expression, that is going to be the rule. Okay? You're going to first cancel, then multiply. The reason is, if you don't do that, you might end up with much harder work than you need. If you do first multiplication, you might end up, let's say you have a 3 times 3 on the top and 3 times 3 on the bottom. You might end up on the top with 9 terms and 9 terms on the bottom. You don't even know how to factor that, much less reducing. So, first reduction, then multiplication, which means you will have to find the common factors immediately. So let me see, factors on the top, 2 and x. On the bottom, x squared minus 4 is x minus 2 and x plus 2. You would know that, right? On the top here, another factor, x plus 2, maybe you can put it this way, and on the bottom you have 2. Can you see the factors now? Of course. You multiply all of that, you multiply all of that, because you're going to multiply numerator, numerator, denominator, denominator. Once you factorize, you can start canceling. One on the top, one on the bottom. Factors. You can see this one here and this one here. X plus 2 is the common factor on the top and on the bottom. You also have 2 and another 2 here. That can also be cancelled. So now you can end up with a x on the top, the only thing remaining on the bottom is x minus 2. Okay? And again, if you want to check your work, plug something. Here for an x and there for an x. Should be equal. Okay? Let me give you one more. So here I need to multiply x minus 1 divided with x squared minus 7x and plus 12. That gets multiplied with the x minus 4. And on the bottom I have x squared minus 1. So x squared minus x, sorry. Okay, this is it. So now, well, I do have a plus here, okay. It will change a little bit, but I'm going to keep it what I have in the lecture. In the lecture, this is an example number 8, so you want to read that in the lecture. Okay. So again, if you multiply this time this, you're going to have a FOIL, and you're going to have, a FOIL ends up with 4 things, right? F-O-I-L. On the bottom, you're going to have 3 times 2, which is going to be 6 things. You're going to have 6 terms. So 4 terms on the top, 6 things on the bottom. And then you have to think about reduction. So we're not going to do it that way. We're going to first reduce and then multiply. So you're going to reduce it first. On the top, this is a prime, so there's nothing really to factor. On the bottom, you're going to have to factor it. So you can reduce it because you need to have a common factor. This guy factorizes into x minus 3 and x minus 4. I guess you would agree with that, right? 3 times 4 negative gives you positive 12. Negative 3x and negative 4x is negative 7x, which is in the middle. So, oh, by the way, right, we talk about it. Find the two numbers whose product is right here and sum is right here. Well, it's negative 3 and negative 4. The next one, this is the difference of 2 squares, so it's x minus 2 and x plus 2, because this is the square of 2, this is the square of x. On the bottom, I have a very simple common factor x, so I have an x minus 1 times x, right? X squared, x squared, x. Now you see the factors. Factor, this one here, the same factor, common factor. Why they are factors? Because you're going to multiply the top. So you have factor times factor times factor, right? On the bottom, factor times factor times factor times factor. So they're common factors. And you have more. Or do we have more? Oh, looks like I don't have anything more. Yeah, because I copied wrong. Yeah, I copied wrong. I shouldn't have here squared. Well, let's have another example here. So that's fine. Now in the paper in my lecture, this is without a square, so I will be able to cancel x minus 4 and x minus 4. That's in the lecture, so it's a different example. So what I have here is x minus 2 and x plus 2. What I have on the bottom is an x minus 3 and x minus 4. And lo and behold, I can't do nothing about it. It's already all primes and they are different. 1, 2, 1, 2, 3. So if I don't have a square, I will have the example like it's in the lecture. So I will have like this. This is another example. All right. So this would not factor. I would get the story of x minus 4. So that's a different example. And now I can factor again. There's a factor here. This is the lecture thing on the blackboard. So I ended up with the what? Cancel. This is the only thing left out of this denominator, but I do have something left out of the second denominator, x. And you can say, some people write this as an answer. This is not an answer. On the top you have 1 left, right? You gotta remember that. When you cancel everything in the numerator, 1 stays, right? Think about this. 2 divided by 4. You cancel 2 and 2, and you're not gonna write like 2 and you're done. No, your 1 stays. What you're really doing, you're dividing with 2. 2 divided by 2 is 1. And 4 divided by 2 is 2, right? The same thing here. And everything you cancel after division. Cancellation is division. Up and down with the same number. You canceling the common factor is the same number has been used as a divisor up and down. So when you cancel everything on the top, 1 stays and must stay, right? You can forget that. If some people do this as the answer. That's a big mistake. First of all, this is not even, right now, you can write this, which will be like a numerator. This is not a numerator. It's never been in numerator. It's always been in denominator. So if it has to stay in denominator, you need to have that as a denominator. Now what are you going to put upstairs? Because you divided with all of this. You divided with this and you divided with this. Okay? So keep that in mind. I have one more complicated example. Let me give you that one. Alright, so this is 15x squared minus x minus 2. And denominator is 2x squared plus 5x minus 18. I need to copy this really correctly. So, alright. Because I cook it, right? I cook the example, so it's nice. 2x squared plus x minus 36. This is example number 9. And down there I have a 3x squared minus 11x minus 4. Okay? That's how it looks. So I'm going to factor this all. Again, you should not be multiplying, because if you multiply, you're going to have 3 times 3, which is 9 terms on the top, and you have 3 times 3, which is 9 terms on the bottom. So now you have a 9 terms on the top, 9 terms on the bottom. How are you going to factor that? If you need to simplify, if you need to reduce it. We never did anything like that. The worst we factor is, I think, 4 terms. The factoring by grouping. We never had anything more than that. So you should not be multiplying. You should do first factorization. So you factor every one of them. Okay? This one factors into. So now this is a trial and error. Oh. Well, it's going to have to factor into a 3x, I believe, and 5x. It might be 1 and 15. You can try that. So I'm guessing. You should do really, really, really nice work here. Okay? But if you do the nice work, it's going to look like that. So let me check this out. 5x times 3x is 15x squared. 1 times negative 2 is negative 2. Middle term. 5x, negative 6x. That's negative 1x, which is right here. Okay, so that's the first numerator. Denominator. Alright, some work. I'm going to have an x and 2x. And I'm also going to have negative I have to have one negative and one positive because this one is negative, right? So I'm going to have let me try negative 6 and positive 3. So I'm doing trial and error, but I'm not writing everything. So there will be 6, this will be negative 6. So that's not going to work because then I would get nothing, right? So let's try 2 and 6. I don't think I can combine that properly. So maybe I should try 9 and 2 because this is 18 as well. So I get 4, I get negative 9, which is negative 5. I need positive 5, so I'm just going to switch the signs. Okay, now check it out. So this time this is 2x squared. This time this is negative 18. Middle term, this time this is negative 4x. This time this is 9x, which is 5x. You should never do it like that. You should always do that nicely on a paper, everything written down, every combination, and then find the right one. Or use AC method. I don't have a time for that, so I'm doing that a little bit faster. But this is the factorization. Okay? The second one, the same story. I am going to factor this as 2x plus 9, the top, and I'm going to have an x minus 4. And then you can check it out, that really works out. I have 2x times x, which is the 2x squared. I have 9 times negative 4, which is negative 36. I also have a proper middle term, 9x minus 8x, which is positive x, right here. And that's the numerator. So I just factor this guy. On denominator, I also going to factor this as, let's see, what do I have? I am going to have a 3x and an x, right? X and 3x, right? So, and then I have 2 and negative 2 here. I need to get negative, so I have negative 2 and 2. Let me try this, and if I don't do that well, I'm gonna try with 1 and 4, and I'm gonna replace the sign, whichever I get. So this is negative 6x, this is 2x, it doesn't work, because I need to get 11, right? And so this is not going to work. And I have it done. Maybe I put 3 over there, or maybe I put 4. Yeah, that sounds right. 1 and 4. Let's see. Alright, this is 12x and this is 1x. So you got 12x negative and 1x positive. That's negative 11x. Perfect. Right? So this is my trial and error. You should never do it like that. You should really write everything down. This is I am doing something fast, because I already actually know what it is because I made it up. But you should actually write it down nicely. Everything is finally completed. Prime, 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 prime. Is there anything in common? Of course there is. Yeah, I cook it up. So this one, common factor. This one, common factor. What's left? One more. This one, common factor. One on the top, one on the bottom. What is left? Well, nothing really. You don't have to multiply anything. This one here, 5x minus 2. And this one here, x minus 2. Okay, you're done. Well, some people that don't know any algebra are going to write here 5. Why? Because they see x minus 2 and x minus 2. That's a huge mistake. Do not do that. Because this 5 is not a factor. And this x minus 2 is not a factor. It's just like a portion of it. That doesn't make any sense. This will be like, well, I'm going to erase this and I'm going to erase this because I have some piece you know, of line that I can erase. That doesn't make any sense, so don't do that. Right? That stays. This is prime and this is prime. There's nothing to cancel here. There are no common factors anymore. So it's a prime over prime, like 11 over 2. Can you cancel anything? No. 11 is a prime, 2 is a prime, and they have no common factors. So that's the end of the story. Okay? Now division. How does this division work? Well, division works just like multiplication. Basically. Okay? The basic idea is you turn the division into multiplication and then it's over. Okay? So I'll give you one example. X minus 2, and I have an x squared plus 3x plus 2, and I want to divide that with another rational expression, x squared minus 4, and that is divided with x plus 1. Okay? So that's a division. You are dividing two rational expressions. This one here with this one here. So you see, oh, it's a whole new ball game. No, actually it isn't. This turns into multiplication, and the basic idea is very simple. Flip the divisor and you have multiplication. So you have x minus 2, x squared plus 3x plus 2, and then you're multiplying and flip this. X plus 1, x squared minus 4. Flipping divisor makes division to turn in multiplication. So you turn division in multiplication into multiplication by flipping divisor. Then the dividend and the flipped divisor become factors. So that's what you have here. Now your next step is going to be cancellation, not multiplication, right? So you're going to have x minus 2 prime. Nothing you can do here, but now that you can get x plus 1 times x plus 2. That's easy to see. Right? This one factors into this. In here, what you see here on the top is a prime. Nothing you can do about it. It's just the way it is. On the bottom you have a difference of 2 squared. X squared, 2 squared. So you get x minus 2, x plus 2. So now you get the common factors. You see the common factors? X minus 2, x minus 2, x plus 1, x plus 1. One on the top, one on the bottom. They have to be factors before you can cancel them. And so what are you left? On the top you have nothing left. And now you gotta remember that what we said already. You have 1. On the bottom you have two things left, x plus 2 and x plus 2, which you can just simply write as x plus 2 squared. Like that. Or if you don't like parentheses, you know, multiply. If you multiply, you get x squared plus 4x plus 4. So that's another option to write it down. This is called in factor format. If you multiply x plus 2 times x plus 2, you're going to get it in the simplified format. Basically without parentheses, right? People call that simplified format. So let me go one more. I have x plus 4 and 2x squared plus x minus 6 divided with x squared plus 5x plus 4 divided with the 2x minus 3. Okay? Again, flip it, multiplication. X plus 4, and I already know I'm gonna have to factorize, so I want to do that immediately. This one here, I have 2x and an x. What else is there? I need to get negative 6, so I'm gonna get that with negative 2 and negative 3, or negative 2 and positive 3, or negative 3 and positive 2, or negative 1 and positive 6, or negative 6 and positive 1, blah blah blah. Lots of possibilities, and I think 2 and 3 is gonna work here. So I can get plus 2 and minus 3. Yes, minus 3x plus 4x. That's gonna give me 1x exactly. So I get 2x and 2x is 2x squared. I got Negative 3 times 2, which is negative 6, and I get negative 3x, and 4x, which I already said is going to be 1x right here. So that's a factorization. Multiplication. What do we have here? We have 2x minus 3 on the top now. On the bottom we have this guy, which is x squared plus 5x plus 4. This one is really easy to factorize. It's 1 and 4. So, okay? So that's an x squared, 4x plus x is 5x, and 1 times 4 is 4. Now it's denominator, right? Because I flipped that. I flipped that because I want to turn the division into multiplication. That's the only way. Okay? And by the way, it's so simple. All you have to do is to flip it and you get multiplication. Now you had the same old story before. If you know how to multiply, that's it. And now you're going to cancel common factor, common factor, common factor, common factor. And now you're done. On the top, nothing left, right? One more time, you have that one example. You have to leave 1 on the top. On the bottom, you have x plus 2 and x plus 1, which is something you can write. If you don't like parentheses, you can write as an x squared plus 3x plus 2. Perfectly good. Either way, I usually get a question, oh, should I leave it this way or could I leave it that way? Either way is fine. If somebody's asking, give me that in factorized format, this is factorized format. Now give me that without parentheses, or they call it simplified format. This is the format. Whichever. Both are equal. There's no difference in terms of, they're both identical, I should say. They're not equal, obviously. This looks different than this, but they're identical, which means that they have the same values, whatever the x is. Okay. One more topic. That is not a rational expression, but it's a story about divisions of polynomials. You thought I forget that, right? Maybe you didn't even think about it. When we were doing stuff with polynomials, we were doing everything except division. We didn't divide polynomials. Well, now we're going to be dividing polynomials. Okay? So at this point, we can start doing it. Some polynomials are very easy to divide. If denominator is, or a divisor, if divisor is single term monomial, then the story is very simple. So I have this example, 2x squared minus 2x divided with x. What do you do here? Simple stuff. Split it up. 2x squared divided with x minus 2x divided with x. How hard is that? Okay? Again, you can do that because, again, 1 over 3 plus 1 over 3, how do you do that? You put 3 on the bottom and you put 1 plus 1 on the top. So if you go in reverse, this you can split. Right? Now I can give you something else that doesn't have everything the same. So like that. 1/5 plus 2/5 is equal 3/5. Not really hard to see, right? Let me just listen. 1/5 plus 2/5 is 3/5 because 1 orange plus 2 oranges is 3 oranges. But going this way, you're splitting it. 2/5, maybe you should write in reverse here. 2/5, 1/5. So you can say, oh, you can do this. Split this. You're not splitting anything, right? This is not a mathematical term. This is called distributivity. Okay? How is that distributivity? Well, this is it. 1 plus 2 times 1/5. That's a 3/5. 3 times 1/5. Distributivity. You multiply this one this, and this one times this. So you got 1 times 1/5 plus 2 times 1/5, which is 1/5 and 2/5, right there. So this is distributivity. But you can call it splitting because it's kind of easier to see that way. If you look at it as a splitting, you can, I just split the numerator. Okay, You can do that. So that's what I'm doing here. I split the numerator. By the way, do not ever do this. Naive people will do that. Oh, I split the denominator. No, you cannot do that. Distributivity would not work here. By the way, this is 1/5. 1/5 of a dollar is what, 20 cents? This is half of a dollar, which is 50 cents. And this is third of a dollar, which is more. So you can't have 20 cents being equal to something that is more than 50 cents. So this is nonsense. Again, keep in mind, you cannot be splitting denominator. But you could do that with the numerator. And what's the point here? Because I'm just going to cancel. Now, x and x, I got 2x. I'm using a power rule if you like. 2x divided with x. Cancel one x on the top and one on the bottom. You get 2x. How about that? X and x get canceled, you get 2. There you go. Division's done. I divided this guy with this guy. This is the result. Okay? So you can do that. Let me do one more example. So this is a simple division. 6x squared minus x divided with 3x squared. All right? Now what do we do with that? Again, split the numerator. Again, this is allowed because it's justified or justifiable. I didn't justify, but it's justifiable by a distributivity. Distributivity works here. So you can split the numerator. So this is again, if you have monomial, single term in the denominator. Now cancel. What do you have here? 6 and 3 get canceled, we got 2. X squared and x squared get canceled, done. X squared is canceling x squared, x is gone. In here, well, you're not going to be able to cancel everything, but you can cancel x and x. So you have negative on the top, you have 1, you cancel the x. On the bottom, you have 3 left, and you cancel one of the x's, 1 is left. There you go. So I divided this one with this one. And you can say, well, you still have this rational here expression. Yeah, I do. I didn't say you're going to have a clean division, right? 6 divided with 2 is 3, but 7 divided with 2 is 3 and 1 remainder. Or 2 and 1/2, right? So division does not have to end up with a whole thing. It might end up with a simpler fraction. But going from this to this will be very much appreciated in calculus because it's much easier to work with this than with this. In calculus and in pre-calculus too. So you are learning that because of that stuff you're going to learn in pre-calculus and calculus. Okay, but what if you have something more? If you divide the polynomial that is not a monomial, it has 2 terms, or 3 terms, or 5 terms, then you're going to have to do the long division. Now I'm going to remind you on the long division how that works. 347 divided with 15. How is that going to work? You remember that? This is how it works. You are looking for the longest sequence here that contains 15. 3 doesn't, but 34 does. And it has it twice. And then you write twice here. You're always very careful about alignment. 2 times 15 is 30. And then you subtract. That's a long division. Some people also write 300 and I subtract. Yeah, that's perfectly fine. So you got 7 here. And 4. And now you ask yourself, how many times 15 goes into 47? It goes 3 times. 3 times 15 is 45. Subtract again. 2 is left. So you can proceed now after the floating point if you like. There's a floating point for you here. So you can proceed after the floating point, but people usually don't do that. And unless they are doing floating point division. Floating point long division. So you stop here. What do you have here? 23 is the quotient. and 2 is a remainder. Okay? Now you can ask, well, I could ask you, how do you know this works? What do you have here? You have 347 divided with 15, and you say the result is 23 and remainder is 2. Which means that 15 goes 23 times in 347, but there is a remainder 2. Now I could ask you, why is that? You can say, well, because of this, look at that. And I could say, how do you know this works? And you say, well, Joe Blow told me that, right? My teacher Joe Smith in the high school was teaching me that, so I learned that and I know how to do it. Okay, do you trust him? Can you reproduce? Let's go backwards. So you have a 2 here. That's the end result. You subtracted 45. Let's go backwards. So let's add 45. Let's go backwards. You subtracted 300. Let's add 300. Okay? Now what's that? This is 347, undoubtedly, right? Yeah, I'm going 2 plus 45 plus 300 is 347. That's what I started with. So I go backwards. It should be. What do you see here? You have 2. What's 45? How do you get 45? 45 you get by multiplying 3 times 15. 3 times 15. How do you get 300? 300 you got by multiplying 2 times 15. You got 13, you add another 0. So you're basically multiplying 20 times 15. 20 times 15. Okay? Now take a look at distributivity here. You have a 3 times 15 and 20 times 15 and 2. So it's, how many times you have 15? 3 and 20. You have a 23 times 15. Okay? This is exactly what you have here. 15 goes in 347, 23 times, and 2 is extra, remainder. That's why Joe Blow, Joe Smith, whoever was your teacher was teaching you that, because this is justified, again, by distributivity. Okay? So you can rely on a long division. Long division is perfect. It's a routine that works. It's justifiable by distributivity. We're going to do the same thing for polynomials. Long division. You're going to have to be a little more careful with polynomials because polynomials do not have floating points. So when you write a polynomial, no floating point, alignment is going to be a little more difficult. You will have to align the terms. So here I have x squared plus 4x plus 5. I forgot to write x. 4x plus 5, and down there I have x plus 1. That's what I want to divide. Okay? I want to divide. Alright? This is easy to divide by doing little tricks here, but I'm not going to do any trick. I'm going to just do long division. If you don't know long division, I want you now to concentrate. Because I'm going to do this on 2 examples, maybe 3, I don't know, 2. And you're going to be doing that for your homework. So I want you to concentrate. I'm doing long division. I'm kind of trusting that you know what a long division is, but if you don't, you pay attention now. Okay? So what we do? Long division. We write dividend here, which is x squared plus 4x plus 5. Okay? And then we write divisor here. And now we divide. How much you need here to find x plus 1 in it? Okay. Well, in terms of numbers, you were only looking for a bigger number. So it was in the previous example, it was 34, because 34 had 15 in it. What's a bigger number here? Is x squared bigger than this one? We don't know, because we don't know what an x is. So the rule is very simple. the degree. So remember what I had. 347, I was dividing with 15. I get a 23 as a result, blah, blah, blah. On the bottom I have a 2. 23 was my quotient, 2 was my remainder. Why was 2 remainder? Why I didn't go on? Because 2 is smaller than 15. When you reach something smaller than a divisor, the division is over. You gotta remember that. When you're dealing with polynomials, what is smaller? Lower degree. That's what is smaller. So here, x squared is already higher degree, degree 2. This is x plus 1, degree 1. Yes, we were teaching you, I was teaching you what the degree is. You need to know what a degree is. Until degree is not smaller, division goes on. Degree here is 2. Degree here is 1. Division goes on. How do you get x squared out of x plus 1? Well, you multiply with an x. That's your first digit. X. And now you multiply. X times x squared is x times x is x squared. X times 1 is plus x. Alignment, no floating point. So square under square, x's under x's, number under numbers if you have any. So no floating point, alignment is by the powers. Okay? Subtract. X squared minus x squared. You subtract, you get nothing. That should happen, because division should go like that, right? Long division goes in that triangular format, when you keep on eliminating from left to right until you're done. 4x minus x is 3x. There you have 5 minus 0, that's 5. You could just say, I dropped the next digit. Yeah, that's like next digit. Now, is the division over or not? Do I have a smaller number here than here? Again, the question is not about a smaller number. The question is about the degree. What's the degree here? 1. Degree is 1. What is the degree here? 1. Degree here is not smaller than degree here. The division continues. Now, how do you get 3x out of x plus 1? You multiply with 3. So there's your next digit, 3 here. Next term, it's not really a digit. 3 times x is 3x. 3 times 1 is 3. Subtract. Okay? You can write like that. I was subtracting here. I was subtracting here. And you really do have to write like that, because if you don't write the parentheses, you're going to be subtracting only 3x. That's a big problem. You have to subtract all of it. So 3x minus 3x is nothing. 5 minus 3 is 2. Okay? It's not 1, it's 2. Now the question for you, is division over? Yes. The degree of this guy is 0. How many variables he has? 0. Degree is 0. Degree of this guy is 1. That's a remainder. So this is your quotient. This is your remainder. So now you can say, I wanted to divide this. What do I have? I have x plus 3 plus 2 over x plus 1. That's the result of a division. This is the quotient. This is a remainder. Remains undivided. Remainder is left over that you could not divide any further. Remains undivided. Okay? Now you can write it like that. Try this. Plug x something, I don't know, 3 here, calculate. Plug x3 here, you see what you got. It will be the same on both sides. I guarantee you that. You can try it. How else you can write this? Well, this is like 7 divided by 2 is equal to quotient 3 plus remainder 1 half. Quotient, remainder remains undivided. You can also say 7 is equal to 2 times 3 plus 1. quotient time divisor plus 1. That's what the 7 is. Okay? So this is analogous to this division format, multiplication format. Let's write it down there. X squared plus 4x plus 5 is equal to divisor x plus 1 multiplied with quotient x plus 3 with remainder added to. Okay? So again, this is dividend. This is divisor. This is quotient. And this is the remainder. The same as here. Dividend, divisor, quotient, remainder. Dividend, divisor, quotient, remainder. Dividend, divisor, quotient, remainder. That's analogous. I'm not saying this is equal. It's not. This is just numbers and these are polynomials. Dividing polynomials. I'm saying this is analogous. Long division with integers and long division with polynomials is analogous. They are analogous. They're not the same, but they are similar. The performance of a long division is done in the same routine. What's the difference? The difference is, of course, you're dealing with variables. You don't know what's bigger, what's smaller. So you're going to use degree. Also, you don't have floating point. You're going to be doing alignment by the powers. Square under square, x under x, so on. So that's the difference. Other than that, everything else is the same. Let me give you another example. Now you can say, this is a difficult topic. Yes, it is. It's going to be one topic you're going to struggle in pre-calculus too. And you're going to have to learn it. There is no way you can get to calculus without knowing this. So let me give you another one. And I'm still having a rather simple stuff. I want to divide x cubed, so I'm going to have something bigger here. I want to copy it right because I want to have, it's nicely cooked, right? All of my numbers here, 1, 1, 1, 1, 1, 2. Not a difficult example. I'm going to have one a little harder one down the road. I'm going to do that one, example 17. So I'm going to do, this is my second example. I'm going to do one more. Okay? So I want to know what is this. I want to do this divided. Okay? So, long division. X cubed minus x squared minus x minus 1 divisor x minus 2. It's important you know what is a divisor, what is a dividend, what is a quotient, what is a remainder, what is a degree. Those are the things you need to know. Right? So when we're learning Latin, there is a reason why we are learning Latin. So we can refer to the things. So this is dividend, dividend. This is divisor, divisor. I'm dividing. Okay? Now you're looking for the longest sequence containing x minus 2. That's an x cubed. It already has it. So you need an x squared to multiply x with an x squared to get x cubed. But then you multiply all of that. So you get an x cubed, x squared times 2, negative is negative 2x squared. Now you're going to be subtracting. Subtract. You're subtracting everything, not just the first one. So that's why I'm putting parentheses. This minus this is 0. Of course, that must happen. X squared minus 2x squared is x squared plus 2x squared, which is, this is negative, and I'm going to have plus x squared plus 2x squared. So I'm going to have plus x squared as a result. Drop the next two digits. They're not really digits, they're terms. But you can look at them as digits. You talk about 225, that's 200s plus 20 plus 5. So you have three terms as well. When we Hindu Arabic numbers, concrete numbers, you also have terms. But you definitely have terms here. You cannot escape from that. Okay, so now what do you need to multiply x with to get here? You need an x. Plus x. X times x is an x squared. X times negative 2 is negative 2x. Subtract. X squared minus x squared Zippo. That it has to happen, otherwise you have more complicated stuff. Minus 2x is positive 2x. So you have positive 2x and an x, which is negative x, which is an x. X minus 1. What now? Now you could say, I am done here. But you're not. Degree here is 1. Degree here is 1. Degree here is 1. Degree here is 1. Remainder must have a degree smaller than a divisor. Not the same. So division goes on. So you say, all right, what do I multiply this guy to get here? You multiply with 1. 1 times x is an x. 1 times 2, negative 2 is negative 2. Subtract. X minus x is Zippo. 1 negative minus 2 is positive 2. So you get 1 as a result. This is your quotient. This is your remainder. Why? Remainder has a degree 0. This has a degree, divisor, degree 1. Remainder has a degree smaller than a divisor. That means division is over. Remainder must have a degree smaller than a divisor. If that is not the case, then you don't have a remainder. Okay, so now we have quotient plus remainder remains undivided. Okay? I'm going to erase this stuff here. I just read that. If you don't believe that this and this is equal, take an x, 3, all right, I don't know, 1.7, use a calculator. Put it here, put it here. I claim it will turn out to be the same. Okay, how can you write in multiplicative format? This is multiplicative format. Dividend is equal divisor time quotient plus the remainder. Now you say, well, I understand that with 7 and 2, but how do you get that? Well, just multiply both sides with x minus 2. If you multiply this with x minus 2 and x minus 2 get cancelled, so this is equal to this. If you multiply this with x minus 2, you get exactly this. If you multiply this with x minus 2 and x minus 2 get cancelled, you get 1. This is the same thing. Okay? So, dividend, divisor, quotient, remainder. In a multiplicative format. In a fractional format, dividend, divisor, quotient, remainder remains undivided. So this is divisor. Let's do one more. Again, you say, well, I'm never going to learn that. Fine. If you're not going to learn this, you're not going to go to pre-calculus. If you go to pre-calculus, you're going to have to learn it. Why would you want to go to pre-calculus? You can go to calculus. Look what is important now. Science is important. We're going to get out of this health crisis with science. We're not going to get out of that with entertainment. Right? Science is important. And there's no science without calculus. And there's no calculus without pre-calculus. And there's no pre-calculus without learning this. So this is what is important. Okay. You learn that on the hard way. Okay? So let me do one more. I want to do 2 times x to the power of 4 minus 4x to the power of cube plus x squared minus 3x plus 3. Oh boy. And I have to divide this with x squared minus x plus 3. Okay? Now you can say, ooh, this is really, ooh, God forbid. Well, it's not that bad. Look at my numbers. 2, 4, 1, 3, 3, 1, 1, 3. I don't have any really bad numbers here. They're all between 1 and 4. So I didn't really give you anything really hard. We can get this much harder. So I want to know what's a quotient, what is the remainder that remains undivided. So again, long division, dividend. You have to be careful about alignment. If something is missing, like you have, let's say you don't have x squared, you're gonna have to leave a place for an x squared because you might have it down the road, so you need to leave that place. But I do have an x squared, it's 1. Okay? So alignment is very important. Divisor. And now the story goes on. What do I multiply this guy with to get here? I need a 2x squared. And then you do it. This time this is 2x with the power of 4. This time this is negative 2x with the power of 3 cubed. And this time this is 6x squared. Look at my alignment. Cube, square, 4th power. That has to be that way. You don't have a floating point, so you have to be careful about the powers. Now you're going to be subtracting everything. You might want to change the sign and do it that way, but you need to subtract. This minus this is zippo. That must happen. This minus this is actually this plus 2x. So you get 4x cubed plus negative plus 2x cubed. So you end up with negative 2x cubed. Do it on a piece of paper if you don't see it immediately. X squared minus 6x squared. Minus because of this guy here. X squared minus 6x squared is minus 5x squared. Drop the next digits. Both of them. Okay? So long division. You can drop both, you can drop one, it's up to you. Alright? So now, what do I multiply this guy to get here? Well, you need a negative 2x. Negative 2x times x squared is negative 2x cubed. And then you write under this times this times this, negative 2x cubed. That's exactly, it must have a match because you want to get rid of it. Negative 2x times negative x is positive 2x squared. Last, negative 2x times 3 is negative 6x. Now you need to subtract. This and this cancels out. Negative 5x squared minus, because it's going to be minus here, minus 2x. Negative 5x squared minus 2x is negative 7x squared. This minus makes plus here when you subtract. So you're going to actually have negative 3, positive 6. That's positive 3x. And the next digit is 3. So I didn't really need that digit, but I dropped it. I mean, it's really not a digit, it's a term. Again, am I done? No, of course not. This is a square here, this is a square here. They have the same degree. Remainder must have smaller degree. So you're not done. One more step. How do you multiply this guy with what to get negative 7x squared? Well, you need negative 7. Negative 7 times x squared is negative 7x squared. Negative 7 times negative x is positive 7x negative 7 times 3 is negative 21. Subtract. All right. This minus this is zippo. They're the same, so you're subtracting. 3x minus 7x is negative 4x. 3 minus 21, that's 3 plus 21, so you have actually 24. What now? You're done. Degrees 1, degrees 2. This is a remainder. Remainder has a degree smaller, degree 1, than a divisor. Then you know you're done. There's no floating point division here. We could have one, but we are not going to go into that. No floating point division here, so you're done. There is only a whole division here. So what do we have here? We have a quotient. This is a quotient. And we have a remainder. That remains undivided. Okay? Now I could erase all of that. By the way, that's in the lecture, right? So I don't have to take pictures now. You could just look at the lecture, right? The same thing is there. Written actually nicer. Right? This is in a fraction format. You can say, whoa. Well, you can check it out. Try an x. I don't know, plug x to be 3. Plug it here. Plug it here. I guarantee this and this will turn out to be the same number. I don't know what that is. It's going to be some big number. Alright? It's going to be some big number. I don't know what it is, but I know it's going to be equal. By the way, it matches my paper. I'm just looking at it, so I know it's right. Okay. Anyway, if you multiply with denominator, then you're going to get multiplicative format. 2x to the power of 4 minus 4x cubed plus x squared minus 3x plus 3 is equal to this guy times this guy. You shouldn't forget the square here, right? It's easy to forget stuff. And I cancel this one, so I got negative 4x plus 24. Now this is easy to check. All you have to do is to multiply this 3 with this 3, make sure you got the proper multiplication. That's 3 times 3, 9 terms, and then add those two, and you're going to end up with this. So you can check that too. That's a multiplicative form. And again, this is dividend. Dividend. This is divisor. Divisor. This is quotient. Quotient. This is remainder. So this is in a multiplicative format. Again, think about it. 7 divided with 2 would be 3 and 1 remainder. So that's, again, divisor times quotient plus remainder, dividend. Or 7 divided with 2 is 3 plus 1 remains undivided. Dividend, divisor, quotient, remainder remains undivided. Divisor here, that's like this format here. Dividend, divisor, quotient, remainder remains undivided. This is divisor. So both are okay. Okay, my story about division of polynomials is over. You're going to find some homework problems here. Again, why do you need this? Well, it's going to be one problem in the test. That's one reason, right? You want to solve that problem. Maybe even two. Another thing, you need this for pre-calculus. If you don't learn this in pre-calculus, you're going to have much bigger problems. What do you need pre-calculus for? For calculus. What do you need a calculus for? You need a calculus for any science and any technology. And without science and without technology, we perished. We cannot all be Lady Gagas and entertainers and actors. somebody needs to do some serious work. Okay? So I want you to understand this. This is important. Make sure you study this. I am done with today's lecture. But we're not done with the rational expressions. We have a part 2 coming, which means addition and subtraction. Well, yeah. You can say, why don't you just do that first? Why would you do multiplication and division first, and then you do addition and subtraction? Because addition and subtraction is worse. It's harder. That's why. So I want to teach you something that is easier. Oh, God. Yeah, sorry. But I'll see you next time. We're going to do rational expression part 2. Okay?